Hey guys, welcome to the section 4.2 activity. I'm going to go through a little activity that will introduce us to the StatKey applet that you'll be using for the first few sections of chapter 4. Alright, so you should be clicking on this link on number 3 to section 4.2 activity. Now I have that open here, so we'll take a look. We want to measure evidence with p-values, so I'm trusting that you've watched the screencast already and have the basic idea of what's involved here. So we want to use StatKey to create randomization distributions and find p-values. So in a study to investigate the effect of drinking beer on mosquito attraction, 43 men were randomly assigned to drink either a liter of beer or a liter of water. I don't think we're given the time frame there. So with 25 being assigned to the beer group, 18 to the water group. The number of mosquitoes approaching each man was then recorded and is shown in the table below. All right, we wish to see whether the data provides evidence that mosquitoes are attracted to beer drinkers, or more precisely, that the mean number of mosquitoes approaching a beer drinker is significantly larger than the mean number of mosquitoes approaching a water drinker. Sorry, I just realized that I don't have the table here. So let's go take a look at the data before we continue on. Now it turns out you can find that data in StatKey, so I'll show you how to get there. So let's go over here to look at the links again. One of the links down below is to StatKey, or you can pretty much Google it, StatKey, with the Lock 5 book. But I'm going to click here, and then it opens StatKey up. And so this is the interface to get to all the applets that come with the textbook, called StatKey to accompany this book. So now let's look over here, the randomization hypothesis test. What we're going to consider is a test for the difference in the means, average number of mosquitoes attracted for those who have consumed beer versus water. So we're going to click through to test for difference in means. And you've seen this output in the screencast before. Now, let's see, we need to click for the particular data set that we're looking at. And usually we can tell by the description the one that we're looking for. So there are just a limited number that go with the textbook. And there's one on mosquitoes, beer versus water. So that's the one, N1 of 25 that got water, and 18 that had, let's see. Sorry, let me just check the sample sizes here again. Let's verify that we've got the right. We want to make sure to know. I'm sorry. X bar 2 has to be 23.6. Or sorry, X bar 1 has to be 23.6. X bar 2 is 19.2 to get the positive difference of 4.28. So that means the beer sample was the one with 25 and the water was with 18. All right, and so that's the data that we're looking at and we're going to use to carry out the experiment. This is the original sample. Now let's have a look at the questions. Is this an experiment or an observational study? So it's clearly an experiment because of the random assignment. We presume there was fully informed consent ahead of time since people were being randomized to drink beer or water. The cases, so there are 43 cases. 43 individual men that participated. And what are the variables? There are two variables. The one is the quantitative variable, which is the response, and that's the number of mosquitoes. All right. And the explanatory variable is going to be the treatment. And that would be beer or water. Beer or water. Right, the two, one liter of beer or 1 liter of water. State the null and alternative hypotheses for this test. So the null hypothesis, well, let's see. So first we should First we should define our parameters. So we're going to define, let's let mu1 represent the average mosquitoes approaching for group 1 beer consumers, and let mu2 represent the average number sorry, that should have been average number of mosquitoes, right? Number of mosquitoes, and average number of mosquitoes. There seems to be some controversy here. The number of mosquitoes approaching for group 2 water consumers. All right, so that's the null and the alternative hypothesis, or sorry, that's the definition of the parameters. So then we've got H naught. I'm not going to worry about the subscripts here. That's going to be mu1 equals mu2 versus the alternative, HA, which is going to be what? So the question we have to look at is what specifically is the alternative hypothesis? We want to see whether this data provides evidence that mosquitoes are attracted to beer drinkers. So if that were the case, we would expect mu1 to be greater than mu2. It's a one-sided alternative hypothesis. Okay. So now we're going to use StatKey to create a randomization distribution for this test. We'll do 1,000 of these first. I'll show you the basic idea, and then we'll assess these particular possible outcomes. Okay, so here we are. Let's just generate 10 of the, let's generate a few individual values. So here's one. We generated a random sample, and if you saw the screencast, that was by randomly assigning these total of 43 to 2 different groups. And for this, we get a difference of 3.9, and it gets plotted up here towards the top. So it's pretty high. We generated another sample. It's 2.75. It's here. This is a totally new sample of 43 by re-randomizing. Generate a few more. Now this one came out to be negative, so it turned out the ones that ended up getting assigned to what was being called the water group had a higher mean for that randomization, so the difference came out negative. So I'm going to reset this and just do 1,000 of these. So this is our randomization distribution. We could generate more if we wanted, but I like the convenience of having 1,000 for our calculations here. Notice if you hover over these points, you'll see that the randomization sample changes. So for each of these, you can see what the sample looked like that gave rise to that. So you can see the ones over here have the beer values higher, and the ones over here have the water values higher. All right, so this is the randomization distribution under the null hypothesis of no difference. We're going to be interested in evidence in the right-hand tail, the probability which would specify mu1 greater than mu2, beer greater than water. So let's take a look. And we're not going to worry about the calculations. We're going to go intuitively. Use the randomization distribution to indicate whether each of the possible differences in means is 1, very likely to occur just due to chance, 2, relatively unlikely but might occur due to chance, or very unlikely to ever occur just by random chance. So let's take a large value like 5. That's way out here, right, in the tail of that distribution. So we would say that that one is very unlikely. I hope I didn't misspeak. Very unlikely to occur, just due to chance. In contrast, I'm looking at this negative 0.5. That's right in here. We'd certainly say that that is very likely to occur, just due to chance. How about these others, like 1? That's right here. That's also very likely to occur due to chance because it's right in the midst of most of the randomizations. How about negative 3? That's over here. That's going to be less likely, but it might occur. All right, very unlikely, or sorry, relatively unlikely, but might occur. And negative 7 is totally unlikely, so that's also very unlikely to ever occur. The 5 was off the charts as well, so that was unlikely. So the only one that we got which was relatively unlikely that might occur seems to be the 1, right? Well, sorry, negative 3, not 1. 1 was quite likely to occur. That was here. Okay. So now we're going to use StatKey to find the actual difference in means observed in the study. And I've pointed that out to you already. That was x bar 1 minus x bar 2. I'm using the notation. And the value that we saw over here was 4.38. Where does the sample statistic lie in the randomization distribution? Is it likely or unlikely? Well, it's way out here off the charts. Now let's see if we tried to calculate the right tail, and let's see if we put in that value 4.38. Now it had to extend the axes just to get there. There were none of the randomizations was as dramatically different in terms of the means as the one in the original sample that we observed. So it means it's almost impossible to occur just due to chance. So let's see, where does it lie? It's at the far right. And is it likely or unlikely? Well, it's very unlikely due to chance. Use it to find the p-value, so it's going to be the proportion at or above. And remember, that's because it's a right tail alternative. We're looking at or beyond this, at or above 4.38. And that value was 0 out of 1,000. So now often we would try to avoid reporting exactly 0 because it happened at least once, the one time that we observe it. So it's not as though we're saying it's impossible that it could happen, but we would say it's extremely unlikely. So we'd say it's approximately or very close to 0. So it's very small. All right, so we're going to take that as very strong evidence against the null hypothesis as we move forward. But for now, we're just focusing on trying to quantify what's the chance that something like that could happen under the null hypothesis if the null hypothesis were true. Right? That is, it's happening just due to the chance variability. And it almost never happened if you took the original data and reshuffled it. All right, so I hope that's starting to give the idea. This is for difference in means. We'll look at other situations in the examples and try to get you comfortable using the StatKey for this so that you can get the intuition of this. All right? Thanks for listening and take care.